All right. Welcome to IT Security Labs, everyone. Thank you for joining me tonight. This is yet another live stream where we will be learning another hands-on information security skill without any BS. So today we are focused on detecting on the host-based side. So when you have a Windows computer, it should have an intrusion detection system or an IDS agent that's listening for events. So today we have a Windows machine that is that. We're going to enumerate it and identify some open ports just like we normally do. Then we need to identify a vulnerable application that gives us remote code execution. In this case, we're going to run PowerShell reverse shell. And the goal is really to see, does our intrusion detection system on the host actually catch anything? Can we see something from the host on Windows here? Then, of course, do we need to do even privilege escalation? And then the most important thing is, what does that look like on the network using suricata and zeek? Then what does that look like from the host using a Wazuh agent? So if this is your first time joining, my name is Howard, and I do these live streams every Sunday at 9 p.m. Central Standard Time. And I'm very excited to be sharing with you because this is part of my journey in learning, and also just sharing with you that it's easy to learn hands-on information security skills. Even if you have never had a job in cybersecurity, you can practice at home and show up to interview and actually show that you know what you're talking about, especially if you have a home lab. So if you like to set up this lab, I have a whole series that will show you how to set up most of these components here. But my Kali Linux is going to be sitting on this network here. It's a flat network. I have a layer 3 switch that is sending a copy of the traffic to a network-based intrusion detection system. In this case, it's Security Onion. In addition to that, I'm also sending alerts from my domain controller down here using a Wazuh host-based intrusion detection system. I actually set it up to also send Windows event logs and sysmon events to Security Onion. So this is by far the most exciting lab that you can actually have, and you will learn a lot. So without wasting a lot of time here, let's jump into what we have today. Our Security Onion is listening. As you can see, I was checking for PowerShell events to see if they are there. We are actually getting a lot of events from our Windows machine. As you can see here, we have Windows. If you want to set this one up, please follow this guide here. This is exactly what I just followed. I think I shared with you last week during our live stream. But set up your Security Onion and then just follow up with this guide that I just shared with you here. And really, these guys did a very wonderful job in just saying, hey, this is what you need with a Security Onion instance. And this setup here, you will have everything that I have running today. All right. I also have a Windows domain controller machine, which is running. And this is our victim machine here. We'll be attacking it. It's on 192.168.38.119. So let's sign into our Kali Linux. By the way, this is Kali 2019 undercover. So I'm just using an existing instance of Kali from a while ago. Okay, let's start with an nmap here. Nmap -sv -sc 192.168.38.119. I like to find all ports, all TCP ports. This is what this is searching here for. So if you hit enter, this will go on and on and on for a while. And what you'll see after a little bit are these ports here. I'll go and show you once it's done. But right away, we should be able to identify that this is a Windows machine. It says Windows Server here. There's a default installation of IIS. It looks like from here. Also running Kerberos, DNS, and LDAP. These three services right away show us that this is most likely a domain controller. It could be a backup domain controller, or it could be the primary domain controller. At the end of the day, this is a domain controller. And for whatever reason, this admin is just ridiculous. They're running a database there as well. They have the terminal service, which is open. And in this case, this is Windows Remote Desktop. Let's just keep scrolling down here. This is a common port that is always there. 9389. We might need to find out what that is. It's a .NET application. We also have an unknown one. These ones are usually the most suspicious ones, especially when you're going for the OSCP or any of those capture the flag challenges. Ports that always show up as unknown usually is some random custom application that was written that Nmap wasn't able to classify. In this case, that's what I'm going to go with, that 20271. All right, so we identified an interesting port. We can start at the top and do it in a methodical way, but to make sure that we save time, this unknown port is what's actually running a malicious, a vulnerable application. So without wasting a lot of your time, let me show you the application that's actually running on that. It's called Wondershare Dr. Phone, and this is the version of it. It's 11.4.8. So somehow you need to have found out that this is the application that's running. And in this case, this application, let's say we found it in its version in 12, Wondershare. Well, we can go to exploit.db, or we can just go to, search exploit. In this case, we start with exploit.db and say, well, what's up with Wondershare? This thing is plagued with vulnerabilities. I'm talking a lot. So we'll pick one from this month. That's how I found it. And in fact, a lot of these are local. And since I'm not local on that machine, well, I'm kind of is, but I'm only interested in the remote code execution at the moment. So I would open this one and say, okay. Looks like this is the easiest exploit that we can ever find, right? There is the app that you can download. This was tested in Windows 10. Is that going to be a problem if we are running it in Windows Server 2016 or 2019? This is 2016 evaluation. Windows 10, Windows Server, usually they'll both work in either case. So what do we need to be able to run this, and what is it? So it says that the affected versions, does it tell us? Okay, it's affected by remote code execution due to software design flaw that an unauthenticated, so we don't need any authentication, can communicate over UDP. So we actually did not scan for UDP ports. So this is almost like a chance for us to know that maybe we should always scan for the UDP ports. So they can communicate with this install assist.exe. This is why I chose this application. So if we are going to be interacting with an application on the machine and we have intrusion detection installed, we should be able to see what happened with this application, or at least this application should show up in our logs if we actually run this exploit. That's really the idea here. And the service is running under system privilege, so there's no privilege escalation. And it will manipulate it to execute malicious executable without any validation from a remote location and gain system privileges. So that's what we have. And this says, let's just look at this quick. It's a Python 3 script. We should be able to run this to cache our shell. So we'll just start by doing that. Let me get rid of this slide here. We'll just use this. Run our netcat. So we're listening on the default port that they gave us, 1337. We're just being good students, just reading a proof of concept and being able to just follow the instructions. Okay. So one thing that you can do is maybe you can copy this entire thing. Add it to your Kali Linux. But there's some cleanup that needs to happen here. And this is something that we have practiced on this channel over and over again. If you're given a proof of concept, you need to understand a few things here. Like, this is a interesting one. Wow, they didn't comment this line here. This line is going to give Python a headache. It's something that we just know. This either needs to be commented out or it needs to get out of here. So I'm going to just delete it. All right. So the first line is gone. And this one is commented out and it just told us to listen. We need socket. So as far as modules are concerned with Python, we're not going to struggle here. We're only using socket, which is kind of nice. The payload is going to be this. We can change this payload to even point to our own niching if we wanted to. Or better way is keep this payload for future exploits. If you're going to be sending a Windows Powershell payload, I would just keep this since we already know it works. But we can always create our own as well. So this is just a standard PowerShell reverse shell. It's like the classic PowerShell reverse shell. The problem is it has hard-coded values here, so it's not going to give us any input. So we need to change this to our IP address for Kali. You only know this if you actually have interacted with exploits before, that you need to change this, or if you can read Python. So let's find out what is our IP address here. 38.186. So we can change the port if we wanted to, but I'm just going to leave it the same way. And looking at this, it's actually going to be scanning for a port, a UDP port, because we don't know which port that application is communicating on. Let me see. And then we also looking at here. Oh, come on. Let me save this. Maybe let's come back with nano. Maybe that looks better. All right, we need to change this to point to our victim. So this is going to be .38.119. All right, so we are going to open a socket on the system. We will be looking for a random UDP port in this range here that we can connect to manipulate the service. Then the service will run our PowerShell command. So let's save this. Say yes, enter. So that just looks exactly like this here. Again, I just edited my IP address here, edited the victim IP address, and removed the noise that was on top right here, because this will not run with Python. All right. We haven't actually spent some time to figure out, like, okay, how does the service actually connect after it executes here? But what we know for sure is that we have it run PowerShell to give us a reverse shell. And for us, as people who are interested in detecting things and knowing how detection works, we are very fascinated by this command here. I see Matthew and BT have joined us. Thanks, guys, for being here. Really appreciate it. All right, so let's go and first see if we can actually run it. But before I do that, I'll just verify that my service is running. It says it's running. All right. And let's check a baseline for our alerts. Let me change this to the last hour. I need to make sure that I know what's new here, because as you can see, we have a lot of things that are here. Let's also look at Kibana. I'll just open it from here. Kibana by far has a nicer interface in this case, where you can actually see these events in real time. All right, so some of these were fired when I ran this exploit earlier. But with that, I'll also update here. I just wanted to get a number, like, okay, how many do I have and what do they look like? All right, now let's just run it. Python 3. Okay, and maybe let me do this side by side so you can see. Horizontal. All right, so I'm going to run my netcat down here on 1337. Then let's run the exploit.py. You will notice right away it's trying multiple UDP ports. Try to see if we can establish a connection. Once it succeeds, we should get a reverse shell down here. All right, I'll just leave this one running. I'm very interested in seeing what the intrusion detection system is seeing right now. If I refresh that, do I get new events? Yeah, so I do see a few more events that showed up here, especially this Windows application event. What is that? Invalid source. Oh yeah, this is just complaining that it's a multi. I have two network cards, and my my security onion doesn't know the source. But look what we have here in the log though. It's that application, the Wondershare application. So we know something is happening with the application. I'm not sure why this is happening or how this alert was triggered, other than it says invalid source. But it's also interesting because you see that it is the application that we're interacting with right now that's generating this invalid source. So at least we see something. Intrusion detection system is working. Is this from the same? Let's check this alert here. This is interesting too. It looks like someone is modifying a registry here. All right, so while these alerts are firing, let's go back and check. Oh, it's still running. All right, so while it's still running, let's go back and keep looking at these alerts. I'll switch to the hunt interface. Let's get rid of this event here. With the hunt interface, I can see events by type. I would like to see the OSEC events, which include sysmon. Then I'll also like to see Windows event logs. And here's a bunch of services that are just showing. But I would like to know a few things. So from here, I can say maybe by process name. Just want 1 hour. Okay, so here's host-based anomaly detection. So we do have anomaly detection with Windows, and that's interesting that this is firing here. What are we seeing there? Or is seeing this Azure app that I'm running. So that one is not the one that's causing problems. All right, Now coming back, this is going forever. Let's go and check our service quick and make sure that it's actually doing what it's supposed to. Yeah, the service is running. Let me give it a minute. If it doesn't, I might have to restart the service because I just did it before. In fact, I'm going to change the port. So we're going to change our port this time to a different one, just in case the port is still taken. 1338. And start our listener on 1338. But before I do that, let me restart the service. Oh, that's interesting. It wasn't running. All right. In the past, I've been able to actually make sure that these services are running by just putting it in a task scheduler to check, make sure that they are running. Okay, now it's running. So that means that we ran this so many times. It should stop very quickly. Then we will get our reverse shell. All right. While it's running, let me see. How many people do we have here? Oh, we have a lot of people. I really appreciate everybody who joined today. This is really exciting stuff, especially the detection side of things, because, I mean, we can attack all we want, but if we can detect, this is really the exciting part of what we do here, is making sure that we can actually see things and also detect things, which is kind of exciting for us. All right, let me go back to here. Task manager. Oh yeah, this is doing well. And I'm just checking for it here. Not bad, actually. Maybe we just need to let this one run. Okay, I'll go ahead and show you what it looks like after the service starts. Then we'll come back and see the reverse shell. It's just going to give us a reverse shell that just says, hey, I was able to successfully run PowerShell. But to make sure that we don't wait too long, let's look at this right here very quickly. First, our exploit includes calling for PowerShell. So if we were to hunt for this in our environment and we're like, we want to know, did this ever run in our environment before? You can go and just search for all PowerShell events, which might be a lot depending on how many things are like scheduled and things are running, especially if you're a PowerShell shop. Or you can go and make sure to understand that this is not encoded in any way. In this case, it's just ASCII encoding. So in fact, I can look for this. I want to see, if I see this, that shows me that we did see these things both on the wire and from the host. Right now, I'm more interested in the Wazuh agent being able to see that. And also suricata and zeek being able to see that. Wow, we saw that a lot of, really? Oh, so this is our scanning right now, actually. Let's pick on one of these. That's a lot of entries, which shows me that every time that that thing is running and it's scanning, it's actually trying the same payload over and over again. Right, there we go. And let me move myself away. All right, so look what's happening here. Well, first let's understand where did this come from. This came from Windows event log. That means that this event here is from the host. This is not from the network. This is from the host machine using the Wazuh agent. So we ran the no op command here, client connect 1337. So this is the earlier entries when I was doing scans. But I want us to pay attention to how many, like look how many of these entries are here. I bet if I refresh here, if it's still going, this value will probably go up. Yeah, it keeps going up. As you can see, it keeps going up. That's because we're doing this. Well, we were running the scan. The scan actually finally finished this time, and we got a shell here, a reverse shell. Let me see if it actually works. All right. So what's the first thing that we can run in a Windows machine? Where am I? NT authority system. So at this point, we know the exploit works. As you can see, we did get a reverse shell on a new port 1338. And coming back to what I was showing you, we looked for the part of the payload, just as part of the payload. And we said, hey, if you were running this and it wasn't encoded, we should see it. And the no-op part that you saw, where does that one start? It started here. Yeah, so what I was showing you is just exactly this. This goes to confirm to us that indeed host-based intrusion detection system works if it's implemented correctly. So at first, we should have been alarmed by just how many of these were coming. If you are doing this for a customer or a client, you should be thinking like, hey, if I run that script that I just showed you today, your customer, if they know anything about it, IDS, they'll be like, well, what's happening there? That's a lot of value. In fact, here are the values that were sent in our brute force. It was literally just going through all UDP ports in the range that it had, incrementing the values one at a time. We also saw ignored values here, which is all the ports that we were brute forcing with. So if you run your PowerShell as part of a payload and you do not do encoding, you're going to be busted by simple tools like the Wazuh tool that we're using here. So that's one takeaway. In fact, they will be able to tell what command you ran. In this case, you ran a TCP socket connect here to this IP address on this port. You were actually doing a scan using this list here, a 0 to 65,000, 65,535. So you actually brute forced all these ports here, and as evidenced by all these on this list here. All right, so in addition to us seeing this, which makes me very happy that, indeed, intrusion detection system works on the host. Or what about the port that we just, got a reverse shell on? For that, we should be able to see that port using zeek, I think. If I do a destination.port, equals to 1338. There should be one entry. Oh, we have 9. Of these, there should be one entry that actually was successful and also contains the data. So let's look at this one first. Okay. So this is just confirmation that we did have from to this destination IP address, which is my Kali Linux on 1338, we saw this event on the network. So I'm confirming that the command was ran on the host using the Wazuh agent. I'm confirming right here that this was a TCP connect event that we did see. So not only was the command successfully ran on the host, it was actually also seen on the network. And let's see if we saw the plain text information as well. Okay, this is a reject one. So we can filter for only the successful ones. But we only have 9 here. Let me just do a quick look. All these are all zeek events. It looks like. This one looks interesting. This is a Wazuh agent file. Again, just like what we saw earlier, this also shows us that, hey, PowerShell was executed. We even have some process names as well. It was a network connection. This is from the actual agent. So this is Windows sysmon. So we have 3 types of events that we have here. Windows events, which showed us the other one, the PowerShell events. This is sysmon, which is just collecting more Windows events here, but also monitors processes on the system. And then we have network events. In this case, the source port that we sent with was 55933 to this destination here. Oh, I'm on the way again. All right. The interesting thing is PowerShell was executed as NT authority. What I'll be interested in is for those who do detection for a living, wouldn't it be interesting every time PowerShell is executed on the system as NT authority system for you to want to know about it? Because if people are going to be running PowerShell scripts, if people are going to be executing PowerShell logging and other things like automated stuff, they should have a dedicated account with privileges to do that instead of just running as NT authority. So I would say we can take it further here and say, if you're going to be running PowerShell as NT authority, I would like to know. Then we can talk about maybe having the principle of least privilege implemented here, where you only run your PowerShell with the permissions that it needs. Because in this case, running PowerShell from NT authority gave us a reverse shell when you abuse the system as NT authority system. So that's something to investigate further. Because my logic actually makes sense here that I wouldn't want to be running as this user here. All right, so that was our reverse shell. What else can we see? Okay, so that one didn't. So suricata did not catch this. Oh, yeah, here's another one. This one is a good one too. Okay. So here, an actual rule fired. So who was this? Oh, sysmon. So this was a sysmon rule that fired here. It wasn't suricata. Suricata has been out of commission here. We don't have any rules there. But sysmon detected a connection, and it was PowerShell, NT system. And now we can confirm, it was this port that we already know about up to that port. With this one, I don't think we get. Do we actually get PCAP for this? Okay, I'm going to try to see if I can get a pickup for this. I've never actually requested pickup from a Sysmon event. So I'm interested in finding out what that looks like. All right, so we automatically get here and it says, yep, this is the offending event, the PowerShell event that we are looking for. And I would like I can do a correlation here, but I want pickup. That's what I came here for. It should be able to show us everything that we did. And in this case, I'm running my pickup agent on the security onion instance. So this is just going to create a job and say, hey, give me pickup for these connections here. All right, while the job is completing. Hey, Saravan, how's it going, man? Thanks for joining. While the job is completing, let's just look at the alerts in general. What else did we do? All right, so you're going to see these ET scans. Those are our Nmap scans. Windows event logs, we have a lot of them. So we might need to do some tuning to this IDS. We have a lot of just Windows events. I'm kind of disappointed with suricata a little bit, because suricata only caught just the scans. We had a service that was manipulated to run PowerShell. I thought for sure there will be a rule that says, hey, if a random application runs PowerShell as NT authority system, we should be able to discover that. So that is kind of disappointing that suricata didn't come. Maybe, yeah. Suricata didn't help much. So that's where I'll probably be spending most of my time trying to fix it. Is okay, suricata, let's get it together. All right, so that was interesting. Let's go back to our pickup. And okay, it's still running. The pickup is still generating, I think. 9, 10. Wait. Yeah, it's still pending. We'll wait for it. I'll look at your comments here. Says, do you have a Discord server? Also, what days do you go live? I only go live on Sundays at 9 p.m. Central Standard Time. So only Sundays. That's when we do that. Then, do you have a tutorial on installing Security Onion? Yes, I do have a video. There's a series on creating a home lab on this channel. It'll show you how to install Security Onion. It's very simple and straightforward, actually. And then once you are done, just follow this guide here on installing the agents if you want host-based intrusion detection system. So I'll just follow this. I did this for both Linux and Windows, and it works. So just follow that guide that I've just posted there. But I do have a whole series on this channel. If you go and look in my playlist on creating a home lab, and Security Onion is, I think, video number 10 or something on that series. All right. Ray says here's PowerShell ISE. I think you're running. Yeah, I don't know why this pickup is taking forever. It's usually very fast for me, but we'll find out. Let me know if there's anything that you'd like to cover, but I'm very excited that we can actually, I mean, put yourself in my shoes. You want to learn cybersecurity skills, right? You either take a certification and go to people and say, hey, please hire me. Or you take a certification, you do what we are doing here, and you show up and say, hey, please hire me because I actually play with these things. I know my way around data and being able to read that data, and I understand what it's doing. And the best way to just really do that, set up your own environment like what I'm doing here and start investigating. If there's something that excites you, like what I do, I only do things that I find fascinating. Just pursue that, and you find yourself just doing it without even it being a chore. Was I get adrenaline rush just running exploits and try and figure out where exactly the alerts were generated on. So for me, the biggest takeaway from today: encode your PowerShell payloads, encode them, and as you move them across the network, because I'm pretty sure that I have an entry in Zeek that has my payload. Make sure that your Wazuh agent is pointing to sysmon, which is very, very easy to do. Then you can have Windows event logs, sysmon events, which is kind of really fun. Once you have a diversity of data points coming from Windows, it's very exciting to actually begin to see. Because one thing that I didn't do here is, which I don't know how to do, I could go and actually track down that service. Actually, you know what? I said too quick. Let's track down this service here. This is our culprit. This is how we got hacked. Let's find out what it looks like. We should have an entry for that service being manipulated by, I mean, this service bringing PowerShell up. That will be a big win for us, actually, now that I'm thinking about it. This service is our culprit, because that's what we were told here. So let's reverse the process and find out, well, how did we end up there? And there we go. Where to start? I'll start with the one that shows us the actual entry. Network connection detected. All right, there we go. That is interesting. So we do see that this was actually executed here. So this service, I'm not satisfied here. This was sysmon. So sysmon should, I wanted to catch it actually executing PowerShell. That will make me very happy to see. All right. I promise I did not practice this. This is just me, like right now as I'm talking, just getting curious. Let me remove. All right. Our exploit said this is there's a flaw in this service here, which is running as NT authority. It will communicate over UDP. So let's make sure that these things actually make sense here. Well, first of all, this was the parent process, meaning that we use this one to execute a command line from the command line here to execute PowerShell. So this is actually, I mean, this is turning out to be even better than I thought. To execute PowerShell, and what did we execute? We executed this command here, this no-op client connect 1338. So if anything, this entry here confirms to us that somebody abused this service per the exploit indeed, and actually were able to get a reverse shell. You'll probably notice something else here as well. This service suffers from the uncoded service privilege escalation. As you can see here, should be say Wondershare service. So that means that if I did not have root privileges, I could have used the uncoded privilege escalation here, because this is one word, but in this case, Windows put double slashes for us. So this is a really terrible application if you ask me. But this entry here is what we will be looking for sure. All right, let me answer any other questions here. What COA would you do if you are a SOC analyst to network infrastructure? If you saw this. If I saw this happening on my network, for sure, the first thing that I would do, I will make sure that this host is unplugged from my network. I'll say, hey, isolate that host. I'll quickly jump back on my IDS and search for that service again, because it might not be one machine, it might be more. So in this case, I'll just go and say, did somebody run that service again? So I'll probably look for this service.exe and check for the IP addresses that show up there. If I see multiple hosts, this will show me that the attackers are now moving laterally from one machine to another, which is terrible news, and you might need to change. You might need to maybe block them or something like that. I also look for any IP addresses that are communicating externally, like new public IPs with data that is going outside. So I'll probably look for, in your router, for like new IP addresses that have data associated with them. Usually if an attacker is stealing information, you'll see like a bunch of bandwidth all of a sudden just start going to this random IP. So I'll be looking all over the place for that as well. But this is an example of a successful attack that happened that we need to just make sure that we investigate. So let's check our PCAP that we were looking for earlier. I have no idea why this PCAP is not showing up. Maybe it's a big PCAP file. We'll just let it be. We already know what happened here because we have a story for it. Then another question, can you suggest learning path for security? If you're very new, go to Try Hack Me. Try Hack Me has an introduction to security path that will teach you very good material. I would go to tryhackme.com and sign up for the introduction to security path. It's really great. That's what I would do if I were you. But of course, in addition to Try Hack Me, set up your own lab environment. Do what I'm doing here, because the more you practice, the more you're actually going to learn. So I highly encourage you to set up your own lab environment. And there's a series on my YouTube channel that you can just watch, and I think BT already linked to it. So please set up your own YouTube channel. I mean, not YouTube channel, your own home lab. There is nothing more exciting than actually seeing real live network traffic moving across a network and you capturing it and you being able to actually confirm. It's just that great. All right, with that, I think that was all we needed to do. So please set up your own home lab. If you have any questions, let me know. Otherwise, remember to like and subscribe. And I will see you next week with another machine. Thank you.